Hello. First of all, I introduce myself. I am Faten Ajmi, a PhD in Crystal Laboratory, and today I'm going to present my work entitled Impact of the Automation of Inpatient and Bed Management to Reduce the Management Emergency Service Waiting Time. I would like to start by my presentation by introduction. Then I will present you the proposed approach. After that, the simulation and results, and finally the conclusion and some perspective. So this work is a part of the OIL project, supported and financed by the French National Research Agency, which is the continuation of the host project. Our experimentation field is the adult emergency department of Lille University Hospital Center, which is divided into three parts: upstream part, the intra-emergency part, and downstream part. In our paper, we focus on the optimization of the global average patient waiting time in the intra-emergency part and the downstream part. This is known as a combinatorial optimization problem. So the combinatorial optimization problems are increasingly big and complex in terms of environmental parameters and data usage, decision variables, and objective function. In addition, sometimes it's not only a criterion, but several criteria. Turning now to the proposed approach. In the emergency department, patients who need hospitalization wait in zone E until an available bed and adequate downstream service is found. Currently, the bed manager team manages the allocation of bed to hospital beds using phone communication. This procedure is considered as a time consuming activity because it increases patient waiting time and thus decreases patient satisfaction. The saturation of downstream service, therefore, has a direct and persistent impact on the overcrowding situation in the emergency department. So, in order to avoid the overcrowding situation in the zone E, and consequently in the whole emergency department, the algorithm that checks the sufficiency of downstream bed based on a genetic algorithm is implemented. This algorithm aims to verify the adequacy of material resource in each department, particularly in terms of the number of beds. To do this, we use the following parameters: omega, sigma, theta. Equation 1 allows us to minimize Fe. That means to identify the optimal values of the parameters omega, sigma, theta, epsilon, and 2 in order to estimate the optimal number of beds in each service E. The automate beds availability information algorithm aims to schedule patients according to predefined order of priority using list algorithm. This algorithm integrates the IoT beacons aspect and allows to create an automation bed allocation process. So the originality of this algorithm is its capacity to adapt to dynamic hospital situation, so in overcrowding and in normal situation. Thanks to the connection created between beacons bed and patient Android application, this algorithm completes in real time the dashboard that could be shared between the different services of the Lille University Hospital. The scheduling solution manipulated by our approach are tested using real database of the emergency department provided by the Lille University Hospital Center. Starting with the experimentation of the first algorithm, which checked the number of beds needed in Service E. Since the large number of transferred patients per year, it is essential to monitor or control the number of resources per service in order to verify their sufficiency in terms of number of beds. The following table shows an example of the result of the first algorithm. So it shows that the percentage of transferred patients can be controlled if we control the number of beds per department. For example, the percentage of 1% of transferred patients can be achieved with 100 beds and an arrival flow of about 40% patient per day and a length of stay of 25 days. Turning now to the experiments and results of the second proposed algorithm. As shown in the following picture, thanks to this algorithm and the beacons technology, the dashboard is completed. The data provides emergency physicians with the necessary information about the status of the downstream beds. Beds can have 4 states: free or occupied or reserved or in wait. In order to evaluate the performance level of our approach, we chose to test it in 2 departments of the Lille University Hospital, the geriatric department and the pneumology department. The following table compares the results found by our approach with those obtained in practice. The same table shows that the average waiting time to obtain a downstream bed found by our approach is shorter compared to actual practice. For example, the simulation period shows that the application of our approach allowed us to decrease the average waiting time by approximately 40%, and 35% in normal situation, and by approximately 30% and in overcrowding situation, respectively, for the geriatric and the pneumology service. Finally, the conclusion. So, in conclusion, this paper present we present in our paper, we use an approach combining meta-heuristic and IoT beacons to improve the inpatient management and resource utilization. We provide healthcare professionals with technology support tool to automate bed allocation process. It is significant to highlight that our approach is presented as a decision support system that reduces the workload of bed managers. The simulation results show that the use of evolutionary algorithm with IoT beacons to optimize the inpatient management is beneficial and practical. We can see several perspectives for this work. For example, we can extend this approach by predict the length of stay of inpatient for each care unit using a learning algorithm such as a Q-learning algorithm. And we can also include multi-agent systems to assure an efficient collaboration between the different hospital systems. Thank you for your attention.